Classic Crackme 0x100. Classic Crackme, find the password, get the flag. We can download the binary. I've done that, and we're going to crack it locally to get the password and use the same password to get the flag. So it says, let the machine figure out the symbols. All right, so I've downloaded this and I put it into Ghidra. And so here in Ghidra, I've actually done some retyping of variables and renaming of variables. So I renamed this, like rename a variable, so I gave it secret value. And I can also retype the variable. That's really handy, because what I saw before was I had something like this. And then you had like lots of these variables. But if I said, oh, okay, this thing is really, if you look at these are strings of characters. So if I say this is really 50 characters long, actually it was 51 characters long, then it does this nice thing. We can actually see the array of all the characters. So we're going to enter a secret password. It's a %s, %50s strings. It allows us to type 50 characters. Then we have these sort of like magic numbers, hex 55, hex 33, and F. And then we do this loop for 3 times. We do all this math on our input and then compare our modified input to the secret value. And if it matches, then when we get the flag. So I could, work on reverse engineering all of this and figuring out how to invert it. I was feeling a bit too lazy to do that. So I'm going to use a SMT solver. There's Z3 from Microsoft Research. And so it will actually find the inputs that will give me the output I want. So we'll see how that looks here. I'm implementing it in Python with Z3PY. So this output string I obtained from Ghidra. So I simply copied each of those letters over. And now I'm going to create an array of bytes, an array of 50 bytes for my input. Now, annoyingly, when you print out the answer at the end, it prints it out in whatever order it feels like. So I created a function that will allow me to sort these names. So here I can basically take a name of this form. So this is like user input 0 all the way up to user input 49. I get rid of the user input underscore. I convert it to an integer. That's going to allow me to sort the output later. I create a Z3 solver. I'm going to add constraints to all of the variables in user input. So all of these bytes need to be proper ASCII values, not spaces. So from 33 up to 126. Now this loop is basically doing the exact same thing as we saw over here in Ghidra. So you'll see that we have a loop that counts to 3, a loop that counts to 50. We have J mod 255 shifted right 1 and hex 55 plus that J mod 255 and hex 55. Then I implemented the next line. Again, you'll see it's basically the same. I implement that third line. This A is decimal 97. So I've implemented this third line. So this loop is basically this in Python. And now here we do the memcmp. We say we're going to have another constraint. The user input after all of this stuff has to equal this string. So ORD converts that to an ASCII value. Then I check and say like, hey, does this thing have a solution? I compute the solution. And now I can go through the model, and I'm now going to go through it in sorted order, sorted again by the name, and I concatenate each of these values, which I've converted to an integer, and then a character to the string, and I print the result. So I can say bin python 3 crackme 100.py, and then it gives me this crazy looking string. Now this crazy looking string I then give to the server. So I'll say netcat titan.picoctf.net 53952 Bam. And there's my flag, solve angry symbols.